Task number 5, UDP and TCP. The most common transport protocols. Also, TCP is the first protocol used in the TCP IP model alongside OSI model. The IP protocol allows us to reach a destination host on the network. The host is identified by its IP address. We need protocols that would enable processes on networked hosts to communicate with each other. There are two transport protocols to achieve that, UDP and TCP, right? So basically we use IP addresses on network devices that use the network in order to identify them uniquely. And then in order to make the traffic work, we need protocols that do that, UDP and TCP. UDP, the user datagram protocol, allows us to reach a specific process on this target host. UDP is a simple connectionless protocol that operates at the transport layer, that is layer number 4. Being connectionless means that it does not need to establish a connection. UDP does not even provide a mechanism to know that the packet has been delivered. An IP address identifies the host. We need a mechanism to determine the sending and the receiving process. This can be achieved by using a port number. A port number uses 2 octets. Consequently, it ranges between 1 and 65,535. Port 0 is reserved. The number 65,535 is calculated by the expression 2 to the power of 16 minus 1. A real-life example similar to UDP in the standard mail service with no delivery confirmation. In other words, there is no guarantee that the UDP packet has been received successfully, similar to the case of sending a parcel using standard mail with no confirmation of delivery. In the case of standard mail, it means a cheaper cost than the mail delivery option with confirmation. In the case of UDP, it means a better speed than a transport protocol that provides confirmation. But what if the transport protocol that acknowledges received packages? The answer lies in using TCP instead of UDP. So basically, UDP is the transport protocol that is not assuring us that our sent packet, our sent request will be successfully delivered. But then let's read about TCP. TCP is the transmission control protocol, is a connection-oriented transport protocol. It uses various mechanisms to ensure reliable data delivery sent by the different processes on the networked hosts. Like UDP, it is a layer 4 protocol. Being connection-oriented, it requires the establishment of a TCP connection before any data can be sent. In TCP, each data octet has a sequence number. This makes it easy for the receiver to identify lost or duplicated packets. The receiver, on the other hand, acknowledges the reception of data with an acknowledgement number specifying the last received octet. A TCP connection is established using what's called a three-way handshake. 2 flags are used: SYN for synchronize and ACK for acknowledgement. The packets are sent as follows. 1. The synchronization packet. The client initializes the connection by sending a SYN packet to the server. This packet contains the client's randomly chosen initial sequence number. Then we have the synchronization with the acknowledgement packet. The server responds to the synchronized packet with a SYN ACK packet, which adds the initial sequence number randomly chosen by the server. And then we have the acknowledgement packet. The three-way handshake is completed as the client sends an acknowledgement packet to acknowledge the reception of the SYN ACK pack. we request the web, I don't know, we request a page from Google. The synchronization is initiated with the server sends back our synchronization with the acknowledgement, and we send back to the server the acknowledgement. Similar to UDP, TCP identifies the process of initiating or waiting or listening for a connection using a port number. As stated, the valid port number ranges between 1 and 65,535 because it is used to octets and port 0 is reserved. Answer the questions below. Which protocol requires a three-way handshake? Is the TCP protocol. What is the approximate number of ports, of port numbers in thousands? So what is the approximate number of port numbers in thousands? 65.